are recording starting right now. So this will be available later. If you want to see it again, you will be able to access it on our website, and I'll be in touch with you about where to find it. So just know that we are recording this. And so we ask that you remain muted while you're not speaking. Just again, it really helps with any background noise that might come up and our sound quality for everyone to be able to understand what's going on. And I see many of us have our cameras on, which is great. I feel like right now more than ever, it's really nice to see some colleagues' faces. So if you are able to turn on a camera, we would love to see you and just, be engaged with us for this hour. So we appreciate that. Another way you could ask questions, if you would prefer not to use your microphone, is you can type it into the chat. And I'm here to support Bertha with that, so I can let her know if there's a question, if she didn't catch it. So please feel free to type away, and we'll do our best to address all of your questions. And if there's any links to share, you may also find them in the chat, and you'll be able to click them, and it'll open up that page for you. Oh, and sorry, I didn't mean to switch to that slide yet. That's about it for now. So I'm going to introduce our guest. This is Bertha Vazquez. She's the director of the Teacher Institute for Evolutionary Science. And we really appreciate her being here. She had signed on to present at our fall conference, and I'm just so excited we could work out this opportunity. So thank you so much for joining us.
Thank you. Thank you, everybody. It's so nice to see people on the other side of the country. I'm in Miami, Florida. And I don't know about you, but I had a kind of a crazy day grading student work. And I saw a presenter last week teaching online, and he was drinking bourbon the entire time that he was presenting. I'm not going to do that, but I get it, because in some ways it's easier because I'm sitting here at home, but in other ways it's harder to teach online like this. Anyway, I'm going to go ahead and share my screen. And thumbs up that you see my screen. Ties, super. Okay, so I'm going to go ahead and come here. And so thank you for being here. Let me tell you a little bit about TIES and get started. So first of all, what is it? TIES stands for the Teacher Institute for Evolutionary Science. I'm a science teacher in Miami-Dade County. I teach 9th and 10th grade science to very advanced 7th and 8th graders. So I've been in the same middle school now for 30 years, but the 7th graders take honors physical science and the 8th graders take high school biology. I had the opportunity to meet Richard Dawkins a few years back, and we discussed the difficulties of teaching evolution in the United States. I told him that I was meeting with local teachers here in Miami-Dade, and he offered to come and speak with them and talk to them about evolution, natural selection, etc. And then he said, would you do what you're doing here locally? Would you do it for me nationally? Which kind of scared me, because I'm a classroom teacher. I'm not a director or an organizer or anything like that. But I took on the task of helping specifically middle school teachers. Why? As a middle school teacher, I have to teach everything from earth-space science to life science. And it's very hard to be an expert in everything, especially initially. So my main goal was to provide content and resources. So anyway, our inaugural workshop took place in my hometown in a collaboration with the Miami Museum of Science. And a lot of our workshops take place in museums, zoos, universities, etc. We collaborate a lot with local partners. So what happened? In 2015, we had 10 workshops, then 17, and then things just took off. 46 workshops in 17, 44, 44, over 170 workshops and 72 different presenters in 50 US states. So I basically train other teachers to present these workshops. I'm in the classroom, so I can't be all over the place. But this is kind of what it looks like. I have an amazing teacher in Oregon, by the way. Her name's Sarah Ruggiero. Don't know if you know her, but she's really, really good, and she's out there. So what do we provide? First of all, we teach content, and I will talk about high school in a second, because we do have a lot for you too, so I don't want you to disappear. But these are middle school science standards for what would be a good state. You know, it changes from state to state. So these are what a good state standards would look like. Secondly, a lot of online resources, and I'll show you that in a second. organized by category. All of our units describe theory because, as you know, the word theory doesn't mean what people think it means. To quote The Princess Bride, people think it's a hypothesis, a guess, when actually it's a very broad explanation to explain a natural phenomena. So that must be a very important starting point in your classroom and outside of the classroom when discussing evolution. This thing, that's another misconception. This line, this simplistic ladder of progress, as it's called, is a big problem when we teach evolution. And this is why we get comments from kids like, I didn't come from a monkey. And you have to say, yeah, no one is saying you came from a monkey. You're coming from a common ancestor. But this is false. But because it's so pervasive in our culture, I tell you to go ahead and Google evolution right now and hit images. And the first 30 images is this thing. So it's very hard to counter that with this. First of all, it's more complicated. And we humans, we like simple answers. So that's another thing, that we have a lot of online activities, very NGSS-based activities, which helps students begin to see it more like a tree and less like a ladder. Scientific inquiry. Of course, a lot of the stuff is the students come to their own conclusions based on their data and their data collection. I like to focus on current evolution, and you'll see it in the unit that I've created for you, as well as a lot of the resources that we have online. Finally, I think this is important in some areas. I don't know about you. Like for me, this isn't really that a big deal. I'm in an urban environment. A lot of my students come from other countries where this really isn't that big a problem. But I do want to stress that religious belief, of course, you don't want to make any child uncomfortable in your classroom. So one of the things that I say to them is, if you had, for example, Richard Dawkins, who's a non-believer, or Dr. Kenneth Miller, who's a devout Catholic who goes to church every Sunday, if you had one of these two great scientists presenting evolution for your class, there should be no difference in the evidence or the data or the content they present. As a matter of fact, they have tremendous respect for each other. And so faith shouldn't be a problem. But I do have a lot of other ways to present evolution in the event that you have kids who are uncomfortable and you want to make them more comfortable in your class. The other thing is, we do provide you with support. If you email me, I can help you. If you're in a tight spot with some parents or whatever, they do have contact with organizations and people that can help you deal with the problem in a way that is respectful, and it'll hopefully make a difference for you. So I want to show you, before I continue, I want to show you the TIES page, because here it is. I did something recently that I usually don't talk about this, but I think this is very important, which is student guided lessons. So the lesson I'm about to show you is for you in the classroom. You download it. Under every slide, there are notes telling you, giving you ideas what to do at each slide, but you don't have that opportunity right now. So the first day I was off, which for me was, gosh, it's crazy, I don't even remember now, I guess like 3 weeks ago, I created student guided lessons. They cover the exact same content that I cover in this unit that you could download and use for your classroom, but it is student guided. Let me show you what I mean. Let me show you this is the middle school one. And the questions are in red for the students. So as you can see, the first thing I'm going to have them do is watch this wonderful video, which differentiates between fact, law, theory, hypothesis. And then they have to answer these two questions. The second thing I'm going to have them do, well, this is just, it explains what evolution is. Whoops, sorry, there you go. It explains what evolution is, which is evolution as a theory is an explanation, and the two main things it explains is the vast diversity of living things that we see on this planet, and how all these living things descend from common ancestors, how we're all related. And then the next thing the kids are going to do is go to this website and click around that tree of life, which I'll like to show you that when I do the one for you. This is a student guided one. Then they're going to go to another website and click around another tree of life. And some of the questions, as you could tell, like this one, what is your favorite animal? It's just for fun. This is a pretty complicated website where they have put every single species, 8.7 million species, in one tree. So it's very easy to get lost inside this tree. That's why I made the question easy, kind of easy for them. Okay? And then the next thing they're going to go over is the different types of evidence for evolution, which I'm going to go over with you. So this is basically a do-it-yourself unit for the students because you're not with them right now. So here, for example, is the law of superposition. Artificial selection. They're going to play some games with dogs in artificial selection. Genetic evidence for evolution. They're going to analyze amino acids. They're going to analyze nucleotide-based pairs and answer questions. And then they're going to hit natural selection. They have videos to watch. They have games to play. And then they learn about Darwin. The high school one is very similar, except I put Darwin at the beginning, and we have way more phylogenetics in there, more cladistics. Okay, this site is amazing. I'm going to show it to you when we do the teacher-led one. This is the student-led one. I hope I don't go, I'm not going too quickly. It's just I cover all of this in the teacher-led one. And it's basically the same stuff, except this is for the kids to do on their own because, like I said, they don't have you right now. Now, the high school one will get into types of natural selection. The high school one will get into gene pool, genetic drift, gene flows, speciation. The high school one will get into human evolution. And then both end with a beautiful example of artificial selection about a fox experiment that took place in Siberia, and an example of how we carry our evolutionary legacy, not just out there in the world, but in our own bodies. This is a dissection of a giraffe. And we all have a nerve that runs from our brain to our vocal cords, except on one side of the body, it runs from the brain around some of the major arteries of the heart and back into the neck area. In humans, it's kind of weird. In a giraffe, it's crazy. And in an Apatosaurus, it's mind-blowingly ridiculous. And these kinds of mistakes, if you will, can only be explained through natural selection and evolution. So these two slides are the last slides in both student-guided lessons. A little more on those student-guided lessons. I have for you student response sheets that I'm going to show you how you could download all of this from the site. So this is so the kids can keep their responses kind of in order. There's a middle school and a high school student response sheet. You also have, yes, you have the rubrics and the answer keys. Let's look at, for example, the rubric and the answer key for the high school one. It tells you kind of how long the activity should take if it's student guided. If you want to break it up, which slides are the best places to break it up for the kids, you know, to assign only so much every week, for example. And then here you have the answers and the number of points that each answer should be worth. Okay? And then finally, I also made exams. So I made high school. This time, let's take a look at the middle school exam. They are NGSS-based exams, so they'll be looking at pictures, analyzing data, making their own conclusions based on that evidence and that data. The high school one has a few more graphs and things to analyze like this and this. So it's pretty NGSS based where they have to analyze and think critically. It's not just recalling information. Okay, so we had it all, added all that stuff about types of selection, etc. And finally, before I go back to the teacher-based one, the assessments, the answer keys for the exams, at the bottom, after the answer key, you have a Google version of the exams where you can share this with your kids and they are automatically graded. It's a Google form. So you can send them the link and they can do the exam online for you. Okay, I think I hit everything. I know what you're wondering now is, how do I get all this amazing stuff? Okay, so you go to your middle school and high school. Say you're a high school teacher. You go here. Now it says, see, what happened was I did this and I put it all over Facebook. And I said, guys, I do not want to put the rubric or the answer key online. Email me and I will send it to you. In 48 hours, I got 625 emails. I was going crazy. This was 3 weeks ago. So they created this form for me because I'm not techie, okay? So the Richard Dawkins Foundation created this form for me where if you click complete this form, you put your name and your school. Let me just put myself in there. So I teach blah, blah, blah. That's my school. See, now here, you can decide what you want me to send you. The rubric and answer key for the middle school unit. Would you like that the Word document where the kids fill in their response sheet? You have the middle school exam and you have the middle school answer key. Similarly, for the high school, you have the rubric and answer key for the unit, etc. So you can get these resources now instead of emailing me. You get these resources by filling in a document. I do ask you to keep those answer keys and rubrics secure. I don't know about you, but my kids have discovered this thing called brainly.com. Have you heard of this? Everything is there. Every answer to every exam question that I've ever given them online, like the Kenneth Miller book, for example, or the USA Test Prep or Brain Pop, everything's there. It's terrible. So I'd like to keep these things away from the kids. Anyway, you can download either the high school one or the middle school one right here. But in addition to that, if you go to see all resources on the web page, there's your high school and middle school again. We have the bell ringers I'm about to discuss with you. You have the classroom presentation I'm about to show you, a lab, an exam, and of course there, if you click on it, it says, haha, you have to email Bertha for that because I want to, again, keep it away from the kids. These are ways to teach natural selection. These are online games to teach natural selection. Different videos on natural selection, addressing myths and misconceptions. These are some games to do common ancestry and diversity, addressing geologic timescale, artificial selection, vestigial organs, homologous structures, etc., etc. And then down here we have stuff for Spanish speakers. We're working on a whole unit in Spanish, but we do not have that one yet. So that's all the resources in addition to the student one I showed you. Also here you can see where our web workshops, our face-to-face workshops are. And we have webinars. We have really nice webinars, and once we do them, we record them. So for example, the evolution of the coronavirus was last Tuesday, and we had over 200 people in that. The evolution of the human brain was a total tech disaster. I'm gonna have to delete that one from there. This one was about a book, and etc. This one's a little more grown up. Everything you know about gender and sex is wrong. I would preview that one before you show it to your kids. Turtles, living fossils, Homo naledi, etc. So all of these are recorded on the webpage, and you could go ahead and watch them and assign them and whatever. So now what I'm going to do is go back to, this is the one that I've created for you. for you in the classroom with your kids. The student guided ones are modifications of this one. So let's say we're all back in our classrooms, which I don't know. I think Miami-Dade County might not go back to the classroom this year. We'll see how that goes. So bell ringers. That's one of the ways to ease that tension that you might possibly have in your classroom with kids not sure if they're allowed to believe this stuff or not. Should use the word accept, not believe. But anyway, we have a fact or fiction bell ringer. Again, all of this is free and all of this is on that resources page, including this PowerPoint. It's right there. I showed you evolution PowerPoint presentation, download it for free. It's in a Word form, Word document, which means you could put your name on it, which means you could delete the slides you don't like. It's yours, make it yours. But I can guarantee you that if you cover this material, you are covering the standards of your state in middle school. And it wouldn't be hard to add the high school stuff either. So anyway, fact or fiction is, when we do a face-to-face workshop, I start with this. It asks kids to read statements about evolution and determine if they're fact or fiction. At the end, you find out that they're all fiction. And the reason I do this at the beginning of a unit is to say, okay, guys, we don't know everything. Obviously, some of you got these wrong. Some of you placed these at fact when they're actually fiction. Let's enter this unit with an open mind and see what we can learn. Another bell ringer, which has worked wonders for me, because I teach evolution right after genetics, is I tell them a true story. And again, you could download this bell ringer for free from the website. I have two dogs. They're actually behind me here. I don't know if you can see them. And one of them, the one on the floor, you can't see her, she had fleas. I bought this stuff at PetSmart or whatever, $70. I still have the receipt. It didn't work. And when I took her to the vet said, oh yeah, that stuff doesn't work anymore. So I asked the students, in your own words, in a paragraph, explain to me why the stuff I bought, which was very expensive, doesn't work anymore. And if you can do a genetics first, I don't know how tight your scope and sequence is, but if you could do genetics first, you very might likely, and I'd love to hear what you have to say about this, but you'll have a child that'll figure it out. There was a random mutation. The flea became resistant. The other fleas died. The resistant flea survived to pass that resistance on to its offspring. And over time, the population adapted, because populations adapt, not individuals. At this point, I put my feet up on my desk and say, okay, well, we're done with evolution. Let's go to ecology. And they give me a funny look. And I know we're not really done with evolution, but that's kind of natural selection. And what does this do? It's like, if they go home and the parents are upset, like, what are you learning about? They tell them about dogs and fleas. I mean, who can argue with dogs and fleas? And I know it's more complicated than that. And the arguments that we have to use to help kids understand this, they're more complicated than that. But it is an icebreaker, and it is a way to get the kids thinking about it in a different way. So at this point, your unit begins. You've downloaded the evolution. And we talk about how in science, the word theory is a big deal. And this is the wonderful video that explains the difference between theory, fact, law, and hypothesis. But I will tell you that I've asked kids to put these in order: theory, fact, law, and hypothesis, from smallest to largest and most encompassing. And I've never gotten the right answer, because it goes like this: fact, because fact is just a teeny tiny thing, like human cells have 46 chromosomes, unless they're, gametes. Hypothesis, a testable statement. Law, which describes nature. And theory, which explains something in nature. Nobody ever gives it to me in that right order. And I tell them, it's okay to use the word theory the way we use it in the common sense. Like, I have a theory the Miami Dolphins are going to win the Super Bowl next year. But you have to understand what scientists mean when they say it. I mean, after all, gravity is a theory. I often say to them, do you want your doctor to wash his or her hands before they operate on you? Why? It's just a theory. It's the germ theory of disease. That's another way to get to them. Or, is the sun the center of our solar system? Why do you believe that? It's just a theory, because it is. It's the heliocentric theory. So we got to get that out of the way right away. Because that, man, I don't know about you, but if I had $1 for every time I heard it's just a theory, I wouldn't be working right now. So then here you go, there's your same standards that we talked about. And then you hit Nova Evolution Labs. This is one I really want to show you because this has got NGSS written all over it. So I'm going to go ahead and go to Nova Evolution Labs. It's really easy to find. First of all, you have the most beautiful videos I have ever seen on evolution right here. But you click on play game. I recommend that the kids go in with a Google, because if you do this over 2 days, they're going to lose their progress and they have to start over. But for today, I'm just going to go in as a guest. Here's one of the videos. We don't have time tonight, but wow, it is just gorgeous. So you go to training trees. And this is the whole idea is I'm going to start with red, green, and oh, here's another beautiful video. I'm going to start with the first mission. They're called missions. What are these for? The whole idea is to get your students to start thinking in terms of a tree and not that ladder of progress. So they move, they move the gecko and the palm tree into the little black square area. Some kids can put it this way. Some kids can put it that way. The whole idea, it's kind of like a Calder sculpture. It doesn't really matter. You know, we always see humans all the way over on the right, like we're the end all be all, and they want you to be able to see that you can move these things around. What do these two have in common? Here's your derived character. I put it here, and if it's correct, the little circles make it to the top. If I put it here, I realize that something's wrong because the gecko is not getting the little blue circle. Put it back. Next, now we have a mushroom. If the kids cannot move the mushroom, that means they must go to the magnifying glass and learn something. Which, you know, they're just going to click out of it as quickly as they clicked in. Now, you also know that your students are going to put the mushroom over here, right? So then we get heterotroph, which again, they have to learn these words using the magnifying glass. And I know that lizards are heterotroph. And over here I have my photosynthetic autotrophs. But no, I don't, because a mushroom, the little circles did not go all the way to the top. So eventually they'll figure out that they need to do this and move heterotroph over here. Yay, so it's closer to, the mushroom is closer to, the fungi is closer to the animal than the plant. Submit. And they have finished their first tree. Here's their second tree. It's a dog, a goldfish, a king snake, and a stick insect. Eventually, they're gonna get this. Now I've done this a lot of times, so it's not really fair. Like, I gotta move this guy over and go that way. You'll be surprised, some of the kids, how quickly they get this. These are your vertebrates, and here's your bilateral symmetry. Ta-da! Of course, they're not going to get it that fast. But so you go through these trees, and they start seeing that tree of life, that common ancestry, in a different way. So that's a terrific activity. We will talk about Darwin. So who is Charles Darwin? This presentation has a ton of videos embedded. You choose which ones you want to show and which ones you don't want to show, but this one's about Charles Darwin. Now here is another wonderful family tree. It's called Evogenale. Can I move you guys? How do I? Aha, I can move you guys. So I go into the interactive tree of life. And again, I think this is the most important thing that you should stress when you teach evolution is common ancestry and vast diversity. So say you pick crocodile here. And it shows you how long ago you and the crocodile shared a common ancestor and what that common ancestor looks like. This is in the student guided lessons as well, by the way. Okay, I'm gonna move you back over there. So then we get into the second standard. The reason evolution is such a very strong theory is because there's so much evidence coming from so many different places. So if you're going to present this in a more NGSS sort of way, don't give them to them right away, all 7 like this. Ask them what they think the evidence for evolution is. You'll always get fossils. The other ones, not so much. So when I do these, I don't want the kids writing so much text. So I make them give me a 2 or 3 word summary of each type of fossil. So for example, a body fossil is an actual remains of an organism. So here we go through the different types of fossils. And always you have an extension. So if they want to learn more about fossils, because what kid doesn't like fossils, you go to the National Center for Science Education article on that. The second evidence for evolution, and this one I rarely get when I do workshops or with students, is the idea of biogeography. And Darwin did write extensively about this. The idea that the modern day sloth is found where the ancient sloth once existed. It would be very weird if the modern day sloth was, I don't know, in Mongolia and the ancient sloth was in South America. The fact that we see the change over time in the same location or studying fossils and the modern species based on geography, that's called biogeography. Then we have the law of superposition. And we do have some great games for you to play on this one, which I showed you in the student presentations. Hold on. These are the 2 games that they can play. This is mud, and someone stole the cookies from the cookie jar, and you have to figure out who it was, and the kids have to figure out the last footsteps. And I know we're pressed for time, so it's the nephew with the dog. If you notice, his footsteps are on top of everybody else's. He was the last person to leave the house. And then they transfer that knowledge to actual, real superposition. So that's how I would teach that and make them think about it, etc. And I love this quote, so I put it in there. JBS Haldane, who was called Darwin's bulldog, he was like a big defender of evolution. They asked him, what would make you change your mind about evolution? He said, find me a rabbit fossil in Precambrian rock. It's never been done. Over and over, thousands and thousands of expeditions all over the world. They've never found a fossil in the wrong place. I think that's very powerful evidence. Then there's artificial selection, another type of evidence for evolution. Darwin wrote a lot about this one. And it's how humans have sculpted other living things. And if humans can sculpt other living things, well, certainly nature could sculpt them as well. I asked the kids if they know what wild corn looks like. There is no wild corn or wild broccoli or wild Brussels sprouts. They don't exist. We've done this. And of course, since who doesn't love dogs? This is an amazing video here. Nova's Dogs Decoded, where in Siberia, they basically turned fur trade foxes into dogs. Over 50 years of breeding the tamest foxes. They've developed floppy ears, floppy tails. They lick their humans like a dog would, and they've identified the genes that are responsible for these changes, the phenotypic changes in the fox. They also bred demon foxes. They took the meanest foxes and bred them together. And they realized it's not behavioral, it is definitely genetic, because when they cross-fostered, when they took tame pups and put them with a mean mom, they were still tame, and vice versa. They also even took tame embryos and implanted them in the mean mom, and vice versa. And the tame embryos remained tame as pups, yeah, and the mean embryos remained mean. So it really shows you, A, that it's genetic. Dogs are are genetically different than wolves. But it also shows you that scientists, I love it, because scientists don't stop at just their experiment. Then they try cross-fostering. Nope, not good enough. Now we're going to try the transplantation of embryos. Scientists don't try to prove themselves right. They try to prove themselves wrong. And that's another thing I really try to push in my classroom, because nowadays especially, I don't know, it just seems like people are trying to prove themselves right. I'm not going anywhere with that, just dropping that out there. And I think it's important to try to prove yourself wrong. Vestigial structures. This is one of my favorite videos embedded in here, the different vestigial structures in humans. And again, I invite you to download this and go through the different videos that are embedded in here that you can talk about. I also have, by the way, I should say this, for every single resource in here, you have the NGSS practices. See, I'm not an NGSS state, Florida, so I forget to say stuff like that. Let me see where it is. I know I have it. I do. If you're really, really interested in that, let me know. And because I created an download NGSS connection, download NGSS connection, there it is. So for example, if I click on that and all of these resources, here you go. All of these resources that I've embedded in this PowerPoint are linked individually as well on my page. You can get all those NGSS practices if you need to show that in your lesson plans or whatever. So this video, for example, is under evidence for evolution, vestigial structures, and you could get the NGSS connections right there. Then you have your comparative anatomy and your comparative embryology. Here you're going to stop and do an activity with the students where they have to take these little embryos and put them in the right order. It's very, very difficult to do. It's in the notes section is where you're going to find all these extra activities. So if you look down here in the notes section, timing is everything. You can see the answer key and you could download that particular activity. So these are just some teachers in Georgia trying that out. Finally, you have genetics, which is just an overwhelming amount of evidence for evolution. You have different experiments that you could discuss, different videos in here that you can show. And I see I'm running out of time, so I'm just telling you that this is available to you and you could play around with it later. But again, if you cover this presentation in your classroom, you're covering all of your standards. And then of course there's natural selection. In middle school, that's the one you have to hit. In high school, you have to hit gene flow and genetic drift and some of the other ones as well. So this is where you can do a wonderful activity called This Lab is for the Birds. And that activity is found right here. This is the Ready to Go Middle School Evolution Unit. Here's the classroom presentation that I'm doing with you right now. And here's the lab with the data collection and analysis that the students are supposed to do with natural selection. So basically it tells you when to stop and do different things. This video here is my favorite video in the entire presentation. And this is a really cute game where they choose a population. They have to make sure there's variation in that population and they try to survive 1,000,000 years. So they can stop and play that game. If you have not covered genetics, I did throw in some important genetic vocabulary in there. Again, you can delete that if you feel like you've already covered that in your class. You can hit some misconceptions, talk about current examples of evolution right here. And the last slide will take you to the TIES website where you can find all of the accompanying hands-on investigations, online games, etc. for your unit. And I don't want to leave you guys with that. Oh, by the way, I also created an elementary school unit Same exact thing, but for elementary. So if you have elementary school friends, there you go. And I want to leave time, Leah, for questions because it is 8:14 and I talked a lot. So.
Great. Yes. Feel free to unmute yourself and call out questions, or I can be monitoring the chat as well.
Water, not bourbon.
Bertha, I joined a little bit late. I had to call a student, but I'm wondering, you showed us a place where we could go to a Google form to get access to the exam at the
Yes.
end. And I don't know, is that on
Yeah.
the website or?
Are you still seeing my screen?
Yeah.
Okay, so okay, sorry, I muted myself for a second.
That's right. I thought I did it.
Okay, so let's say you go to the TIES webpage. Here's the TIES webpage. Oh, she just had a baby today. The lady in the center there, which is pretty cool. She helped me put together that elementary unit. Anyway, sorry.
It's okay.
So here are the guided units for your students to do on their own. And let's say you hit high school. It doesn't matter which one you hit. Here it says complete this form. And it's going to take you to a request, to make a request.
Okay.
And when you make this request, I'm just doing it right here where it says answer key for the middle school or answer key for the high school. It'll take you to an answer key. I'm going to show it to you. And then at the bottom of the answer key, it says want a Google Forms version, click here.
Okay, great. I just didn't know where that first link was. Thank you.
So yeah, you go request the resource for the student guided lessons and go to the answer key for the exam.
Perfect, thank you.
I saw a question, can we request all of the resources even though we teach only high school?
Yes, and share them, share them, share them, share them. They've been shared thousands of times as of today. Yeah, you could just click all the buttons. Look. Boom.
Bertha, I have to say that when I was in college, evolution was my favorite class, and I work in a very rural, very Christian-dominated school district and town, and I've been called a lot of things, and your tactics on what are they gonna do? Tell the kids that they're talking about dogs and fleas. That's amazing. Like, I love that. And I totally need things like that because I mean, you ask a kid a simple question, how do you describe that, you know, all of these things have the same genetic information? And they're like, well, some people would say it might be evolution, but they're wrong. And I'm like, okay, that's fine, but you need to give me an answer. And then they're too timid to say, oh, God did it. And I'm like, well, here's the thing. If you're going to tell me that the answer that you already wrote down is wrong, then you haven't answered the question. So buck up and be what you want to be or not.
First of all, thank you for doing what you're doing. You are amazing because I deal with maybe one kid every 2 or 3 years. And it's been years since I've dealt with a child. What did help for me was Kenneth Miller has a book called Finding Darwin's God. And Francis Collins, who headed the Human Genome Project, has a book called The Language of Science and something. Francis Collins, both believers. Now, Miller is a Catholic, but Francis Collins is actually an evangelical Christian. And I tell them, it's okay. what you think and, you know, what you've been taught. But if you're going to get information about evolution, please get it from somebody who actually knows about evolution. And Francis Collins is a perfect choice for that, because he's an evangelical, so it's their own, you know, their own group. I never offer Richard Dawkins books because that would just be crazy. But I'll tell you though, Richard Dawkins told me that when he has creationist friends, I didn't know they had them in England, but when he has creationist friends, he buys them Kenneth Miller's book because he really admires and respects Dr. Miller. So I think the best way to do it, also BioLogos. BioLogos is an organization started by Francis Collins and his partner Jiberson, Dr. Jiberson. And those are evangelical Christians trying to reach out to their fellow evangelical Christians. And they're doing it in a very non-threatening manner.
And what was that called?
The Language of Science. If you look up Francis Collins.
Yeah,
but
the bio.
Oh, BioLogos, Logos.
And
I,
what was that again?
BioLogos is Francis Collins's webpage on trying to reach his fellow evangelicals.
Okay.
And I'm adding these to the chat as I hear them. So that's, I'm trying to put some links in there to help you find some of these resources.
And finally, and I will share this with Leah, I have a webinar coming up by Brianna Pobner. She's the director of the Human Origins Project with the Smithsonian. And she has started a whole project with data to back her up on how to reach these kids in a respectful manner that won't turn them off. And I didn't make a date for her because I had such a disaster last week with the evolution of the human brain that I wanted to make sure the platform was viable before I invited her on. But I really, Elizabeth, I think that's one you really need to watch because she knows a lot more about that than I do.
And what was that? I'm sorry, my dog.
It's going to be an upcoming TIES webinar, so it'll be on our webpage, and we announce all the webinars on our TIES Facebook page and TIES Twitter by Brianna Probner, and she runs the Human Origins Project at the Smithsonian, and she's found a way that has data-based, it's backed by data to reach kids from these backgrounds that we may not be able to reach them.
My struggle is similar, but I used to teach in the classroom and now I teach online. And I find that if I have kids in my classroom, I can approach evolution in a way that they will accept it. But my problem with the online is the parents are a little bit more involved and they just get me before I can even teach a kid and they just want them excused from it. And so we're just trying to figure out a way to make it approachable for them to even think about learning because they won't even go into any of that information. And I'm like, literally, we're learning about fossils and the formation of the universe, like anything like that. They just will not even, their parents won't even let them be a part of that. And we tell them it's part of the standards and try to go on, what the beliefs are here in Oregon and how that should be approached. But I just can't seem to get the parents to understand that, to let the kids participate in that. It's a real struggle.
I have to bite my tongue in those situations because no, your kid can't be exempt. It's like if they were exempt when you taught the laws of motion. I mean, I don't understand that mentality.
Yeah, I mean, we had the games and stuff, we would play like different forks they would use to do like a Cheerios game when I was teaching it in the classroom. And the way we looked at fossils, I mean, the kids wanted to participate and they didn't even really realize they were learning about evolution. But, obviously it's online. So it's, kind of, and it's actually Florida Virtual is the name of the program that I have. Sure. But I just can't even get the parents past that to let the kids participate and and then I have to come up with alternative assignments, but they don't cover what they need to be covered. So it's just really sad.
Let me, I'm yelling, I'm screaming at myself. I got to get Brianna Pobner on. And if is there any way to make sure that these teachers, Lisa and Elizabeth, can know when that webinar is going to take place?
Yeah, I'm going to push through a link in a few minutes for our exit survey. Please fill it out with your email address, and then I send everybody a PDU certificate, And I will also talk to Bertha about making sure we have info included in that email for that webinar so that you'll get it that way.
Yeah, I will set a date with her and cross my fingers that we don't have a crash like last week, but I see the importance of what she is going to teach us all how to do better, which is reach those kids.
So one thing that I wanted to point out to Lisa is that in my classroom, what I do is I just tell them, I don't care where on the scale you are of accepting it or not accepting it, but what I won't accept from them is not acknowledging that evolution is real and it happens. So the way that I do that is I tell them that there are some people in this world that still do not accept that the Holocaust happened. And they all just get these really bizarre looks on their face, like, what are you talking about? It totally happened. And some of them just get really upset about it. And I'm like, exactly. But people all around the world are denying, they destroy evidence, da, 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 da. So you can choose whether or not to accept the evidence as it is, because I've given you a lot of it, or you can stick your head in the sand and act like it didn't happen. But
That's brave, Elizabeth.
as you can see, some kids don't really like me, but I kind of put it into them in a way that it's like, you have the option to choose. And I don't know what age you teach, Lisa, but most kids learn about the Holocaust. So that might be a way to start.
Yeah, I've never had problems getting the kids to accept it when I had a classroom, but this is different when it's sort of like a homeschooling is what people
Right.
think. The parent is right there. They won't even let the kid, but in high school, they have to participate because you can't take a biology class and get credit if you don't go through that. So because I have a family, I asked her why the middle school kid wasn't there. And she's like, because I don't believe in some of the content that you teach, but but the high school girl is above where she could teach her. So she's allowed her to go in, and she tells her, that just pretend that you believe in this stuff and that you understand it, but you don't have to or whatever. And so that the kid knows she has to participate because it's a high school thing, but it's so middle school, they feel like they can just say they don't have to be a part of it. Whereas in high school, they know they have to, or they won't get the credit for the class.
That's the big push. That's, I think, why a lot of kids are homeschooled, because of evolution and climate change. And I have a friend in Georgia who also does the flea thing. And she thought the flea thing was a great way to introduce the unit, because the kids get home and, what'd you learn in school about evolution? And the kids explain the flea thing. And I know their problem is more speciation and one species over time becoming another. But again, they get home and no one can argue with that, the fact that that flea medicine doesn't work anymore. I also have a video on that PowerPoint that is bacterial resistance over time. That's an amazing video that shows how they make bacteria resistant to antibiotic. So if you show common examples like that, it's kind of hard to argue.
Well,
I guess.
like very relevant, because I think that's things that affect our lives right now, right? Like if you get
Right.
MRSA and you can't get antibiotics, you could get really, really sick. So
Yeah.
that might kind of be a way of, like, even you don't have to believe in evolution, but there's information that you need to know just to make decisions, right?
I feel like they're handicapping their children, because this is a global market today. It's an international market. And for a kid to get to college and not have evolution under their belt, you're handicapping your child, because you need evolution to do medicine. Look at the evolution of the coronavirus. I mean, they're talking about how the fact that this virus doesn't mutate as quickly as other viruses, so a vaccine is probably going to be more effective than a flu vaccine that has to be changed every year. How do you understand that if you don't understand natural selection and evolution? And the other thing that drives me crazy is when I think about what I'm most proud of about this country, one of the things I'm most proud of is science and NASA and getting a man on the moon and our medical breakthroughs and discoveries. And it makes me sad to think that, I mean, that's just my personal opinion, but it makes me sad to think that we're handicapping the kids. On a positive note, if you ask people in this country under the age of 30 if they accept evolution, the number goes up quite a bit. compared to just a general all ages. All ages, we're still hovering in that 52%, but above, under 30, more than 60% accept evolution. And I think that has to do with better science education, better textbooks, better science communicators like Bill Nye and Neil deGrasse Tyson, etc.
Now, I'm retired. Hello, everybody. And I can remember my first 6th grade teaching experience in 1973 with students being excused from the classroom because they didn't believe in cave art paintings, which that was my first year. Anyway, I think science folks need also look a little bit at historical context of these views. I've just been reading a wonderful history book by a Harvard woman, Jill Lepore. It's called These Truths, massive book, 800 pages. But the chapter on the Spanish flu is particularly interesting right now.
Yeah, I bet.
And she talks about how in the wake of World War I and then the Spanish flu, the evangelical community began to grow dramatically, blaming the secular world and the horrors of World War I's carnage and the disease and the rampage that went around the globe after on modernity and evolution. Their first target became the teaching of evolution because they held the secular, technical, modern society responsible for this unraveling of the globe. And William Jennings Bryan, who we all know from the Scopes trial, ran for president 3 times. The Democratic Party was appalled at social Darwinism. They did not like the way immigrants were treated. They felt that Darwinism was behind laissez-faire economics and catastrophe for poor people and working people. So there's some, you read that history, you understand where the 20th century creation science movement had roots in what was actually the more progressive political, social viewpoints of the time. Anyway, so that's a little context for where that background comes from that isn't addressed when you say, here's the evidence for evolution.
To piggyback on that,
pardon me?
To piggyback on that, one of the featured webinars on the main page, the Times main page, is called Maddening Evolution Misconceptions with Stephanie Keep. She goes over the history of evolution education in the United States. And that's a really good webinar to watch, because if you ask Americans, 62% think that creationism should be taught alongside evolution. That's a Supreme Court case back in like 1980 something that banned creationism from the classroom. So it just shows you how people, like you said, Kip, don't understand the history. So I really recommend Maddening Evolution Misconceptions with Stephanie Keep. She's been one of our better webinar presenters.
Some of you may know the book Monkey Girl.
No.
Remember the title Monkey Girl a few years ago? And I believe that's the trial, I think in Montana, about a school board that wanted to have a creation textbook recommended or available to students. And I think Miller was the key witness and testified.
Oh, well, yeah, the Dover versus Kitzmiller trial.
Right, right. That's the trial of that book.
In 2006.
It's a wonderful history of all the issues.
I love bringing up Dr. Miller because he is, I think, our greatest defender of evolution education in this country. And he goes to church every Sunday. You know, I ran into him at the NSTA meeting in Nashville, and I had like one of those really fangirl, nerdy girl moments because he was coming down the escalator and I'm, oh my God, it's Kenneth Miller. And I had to stop him and talk to him. And I felt really embarrassed later, but he was a very nice guy.
I remember when Dawkins spoke at Cleveland High School in Portland, and he started off his talk with, each of you is infinitely improbable.
Yeah.
And I thought you linked that to religion with, and of unestimable value.
I have to say, you know, when he asked me to start this, I said, Richard, you have to let me do this my way. I understand education in this country, and he has given me full reign. He's wonderful, and he understands that you can't just kick kids out of your room because they don't accept evolution, which is what he would probably do. But and he has some great books too, like the Greatest Show on Earth, which is all about evolution. His writing is beautiful, I think. But he's not somebody that I use as an example for these kids because, you know, he's not a religious man.
I want to chime in if I can. Hi, Kip. We had school together a while back there, as I recall, at Lewis and Clark. One of the concerns I saw when you were flipping through the slides, and I wrote this on the exit form, there's a pen and ink sketch of comparative embryos.
Yeah, the Haeckel thing.
The Haeckel thing, and that's been debunked. And I just want to be, as I understand,
it's not been debunked. I mean, the embryos are similar, and the earlier embryos are really very similar. What Haeckel did was exaggerate the similarity.
I guess that's my point. So when I was writing a book, and one of the things I shared with him was I said, look, I used this slide for years, and it's false. It's misleadingly similar, so it's twisted. And I guess my concern is when you have any pieces of evidence that have a sordid past or a problematic provenance, you've got to be a little extra careful, because if someone pulls that out. Now I saw your later images that had some much more appropriate and actual photographs. Those are fine, but I would either treat the Haeckel drawings as a problem with an evolutionary agenda that is kind of what drove them to be misleading.
Right,
But
and you're right, and I do tend to mention that in my face-to-face, I bring up the whole Haeckel argument because they've latched on to that one.
Right, but be careful, because if you get students or school or teachers latching on saying, "Look at this," I had bet on which column you are, and I revealed it one at a time, and it was sort of entertaining for people to pick. But you have to be overly careful.
Yeah.
On such a hot button item, and I guess either put in a cautionary note when you present that, or just include the actual images that are still very significant and very appropriate.
Yeah.
Not quite that far skewed.
That's a good point. Actually, I was teaching this. There's a creationist at my school. And he happened to walk in the day the embryos were up there and the kids were trying to put them in the right order. It's a little puzzle. He's like, huh, so you're still using that, huh?
Right.
And I actually had to go and look it up and see what he meant by that. Yeah. And then I learned what the fuss was about. So that's a good point. Thank you.
And there's a wonderful book that's out, I'm sure it's out of print. It was from 1983 called The Great Evolution Mystery, and Gordon Rattray Taylor. If you get a chance, it's really thoughtful. It's basically poses questions like, why don't we have six-legged mammals? Just why have there never been six-legged mammals? Why are there ant mimics that don't have any natural predators? And it's a very thoughtful thing that raises things. Unfortunately, he died before he finished writing it. His wife finished it up, but I kept flipping to get to the answer and say, what's the right answer? And there wasn't one. And coming at this from the standpoint that we are in a position of never knowing what the answer was, because we can't go back and see it. We never will have factual, here's the relationships fossil-wise or otherwise. Fossil-wise, we can conjecture very strongly, but this is unknowable material. Whereas cardiac physiology, we can nail that.
Right.
And just leaving it with a humility and teaching it with a humility. I'm a high school teacher, and I hit juniors with the biology as opposed to freshmen. The humility is kind of an important piece to bring to the table. So as much as it's foundational and completely solid theory, it's still got edges. And epigenetics has done a wonderful job as far as streamlining some of that and showing that there are some interesting aspects that sort of overlap and do explain some things that natural selection wouldn't. So there's a tone, and I want to make sure that that's kept even from the very beginnings in middle school, that it's messy, and it's okay. Science is always messy.
Yeah, and it's okay. Scientists are okay with not knowing.
Absolutely.
And I always tell the kids, like, not knowing is actually more exciting because you could look for answers to questions you didn't even ask to begin with. You might be led in another direction.
Yeah.
And that's, I think, what bothers some people about science is that we're okay with not knowing.
Oh yeah, that's we have students do science projects and they come out with data that's sort of like, oh, this is ambiguous. I'm like, welcome to science.
Yeah.
The only things that aren't ambiguous are labs that we prepare and finish up in a class period. And that's not science, that's cooking. So the idea of having them recognize that there's ambiguity and there's some things that are telling and some things that aren't, and some of the best discoveries were made while you're looking for something else.
Mm-hmm.
So there's some really deep, rich science if the approach, and that's I'm in private school, so I can sort of play the fringe and not have to worry about the standards. But when the standards become as rigid for science curriculum as they are for calculus, there's a problem because math and science and English and science, they're just not the same entities.
Well, I feel like we're talking about the nature of science and how important that is. And it's kind of unfortunate that it's in the standards, but it's easy to miss, right? Because it's not the performance expectations spelled out. But to me, so much of this is about students understanding the process of science. And again, how things can change, and looking at modeling for coronavirus is a perfect example. Like, it doesn't mean people don't know anything. It means we're getting more data, we're getting better information, and the model will change. And I think a lot of kids if they don't understand that, they're going to become adults who just don't really believe anything scientists say. And so that is such an important piece.
I think everybody gets there eventually. I think everybody sort of hatches along in the same way. You get a much more nuanced sense of history when you've seen more life. You know, I mean, it erodes. We slowly get inroads in there, I think. But no, it's valid. And
Mark Twain said the problem is that intelligent people are always so unsure of themselves, and average intelligence, they're just cocksure of themselves all the time.
That's right. That's right.
I
Most
noticed
confident
the
people.
picture,
Darwin said that too.
the pictures in your slides of Darwin, and usually in the classroom, is generally an old man with a beard,
That's right.
dyspeptic, aging Victorian gentleman. And I think it's fascinating if you introduce students to the Darwin of the voyage. He's 22, 23, he's over 6 feet tall.
The HHMI video is fantastic.
Yeah.
Yeah.
And by the way, the video in the presentation, it's the young Darwin. It's a historical recreation of the voyage and all of that. So.
Thanks everyone so much for joining us. I hope you'll fill out our exit survey so we can be in touch with you about the upcoming webinar. And thank you, Bertha, for joining us from Florida.
Thank you.
Everything that's happening, it's so great this could still happen.
Yeah, it's a strange time.
Thank you.
Thank you very much.